Okay, welcome everybody. So this is the presentation of a master's degree in ICT for Internet and Multimedia, a MIME degree. Here, the Department of Information Engineering of the University of Padova. And you're all welcome here today. What we do now in this hour, we will introduce you to what we do in terms of courses, teaching, also a little bit of research, what you may expect from this degree, what you will probably learn, and also on the various opportunities that we have in terms of internship, industrial collaborations, mobility programs, and all these things. Myself, I am Michele. I am the head of the coordinator of this master degree, Michele Rossi. I teach 3 courses in this degree. Also with me today, there are Federica over here, and Luca, Professor Palmieri and Professor Battisti, who are going to also take turn and introduce and discuss with me the topics and the offer. Okay, first of all, this presentation will be recorded. Of course, it's being recorded, and it will be probably also uploaded somewhere in the institutional website. Okay, this is the first slide that you see today. Is actually a snapshot of our new website. So you can go there, and here I have also added the link, the address that you can see over here, to get more information, and especially to get information about study plans, the different tracks that we offer, a little bit of the research that we do, and some news. So this has been recently refreshed, is a brand new website. So, and we try to keep it updated with some information on what we do and internships and so on and so forth. So you're invited to go and check. So we start with a broad view introduction, of what is ICT, because this master degree is about ICT, information and communication technology. Broadly speaking, those are systems, and then we talk about hardware and software for transmitting, sharing, and processing information. Where it's not only digital information, although digitalized information is becoming the dominant form of communication and information that is available nowadays. This is covering, is pervasive, I would say. It's basically use this ICT technology across a wide area of products and of things that we use in our everyday life. As you know better than me, because you're all young students, you're for sure using the internet, using mobile phones, and all these things are basically exploiting this ICT very much. This is a slide where I just want to briefly, this is a market, let's say, visualization to see the value, the capitalization value of a company, which is Zoom, that we are using right now for this this discussion, this meeting. And you see that the market capitalization for Zoom is $151 billion. It was like that in 2019 and 2020, in October 26, 2020. And this is compared against other companies that are in the aviation sector. So you can see that what we're talking about, this industry, which is around ICT, this is just an example, is actually very valuable. So this is the meaning of this slide. And we are in touch with many companies, and we can tell you that companies are looking for ICT engineers, for people who are able to understand, to program communication devices, to understand communication technology, to understand the technology that is behind the internet in terms of internet protocols, to understand photonics, to understand antennas, to understand multimedia, and all the things that we are going to discuss later on in the presentation. This is about the teaching offer that we have, which is covering, as you can see, 8 main tracks. They are appearing right now as I speak. So we go from communication technologies to internet and security. Then we have a smart industry track where we have ICT oriented toward the smart industry. Then we have a track dedicated to multimedia and digital arts, a track dedicated to quantum information, one track dedicated to photonics, and two tracks dedicated to ICT for healthcare. So here we have one which is oriented a little bit more on machine learning things, and the second one which is oriented medical ICT towards the ICT technology that is needed to process, transmit, and acquire medical information. So briefly, and then I will go in more details. So this is just a first idea, and those are 8 tracks that you can choose in order to for your study plan, basically. So and then as we move on, you will get more details about each and every one of these tracks. So as I was saying, ICT is pervasive. And I can mention many things like the internet, home banking, multimedia streaming, YouTube, Vimeo, Prime Video, and so on and so forth. You're using emails, mobile calls. All these things are relying on ICT technology. But this is only the tip of the iceberg, because nowadays many more technologies, many more, let's say, application-oriented fields are emerging, like smart cities. And here we talk about the Internet of Things, all these sensors that are placed around the city to monitor the traffic, to monitor the pollution, and so on and so forth. The technology that we are using indoor in order to build smart buildings, right, for the safety of people and also for being comfortable within the building. Then also this technology about vehicular networks. So because we know that cars are becoming intelligent and autonomous driving is around the corner, and cars will be needing a lot of technology there to communicate, because cars will be able to communicate as well in the near future. This is not taking long to happen, I'm telling you. And in the cars, we're going to have also radar technology and LiDAR technology that we're going to talk about later on in this presentation. Then we have this multi-access edge computing. So the mobile network that we are all using with our cell phones is evolving. And in the past, when it was like 2G or 3G or even 4G, what they were mostly doing there was communicating, transmitting voice, transmitting data, and getting data from the internet, as we're doing every day. In the future, they are augmenting this mobile network with also computing capabilities. And they are coming up with this new concept of multi-access edge computing, which is called MEC, which is about having the base station, the cellular network, offering communication and capabilities integrated with computation, and learning. So we have now that communication will be performed jointly together with computation and also with machine learning tools, basically. So we are learning things at the network edge within the mobile network itself. Now we have this multimedia that is becoming pervasive. So we have a lot of technology there, and then Federica will be talking to you about that in more details of what I can do, which is about knowledge extraction and manipulation of videos, point clouds, knowing how the augmented and virtual reality tools work and are basically designed, and so on and so forth. Nowadays, there is this cool, buzzword, the metaverse. But this is actually technology that we cover in this course in terms of mathematically and also in terms of software that you need to create a virtual environment, basically a virtual reality environment. Then there are new emerging communication paradigms. We are talking about intelligent surfaces. So we can have in a building, for example, in a smart building, we can have some of the surfaces, some of the walls that are constructed by using some material that can be used to reflect, the radio waves in a way that is basically relaying information. So you're exploiting the reflection of a wall in order to transmit the information where you want to. So in a sense, the building is behaving itself as a sort of a distributed antenna system to communicate and distribute the information within the building itself. Then we have underwater communication. So this is a new paradigm of new mobile networks that are happening right now under the sea. Massive MIMO technology, which is about using many antennas within a single device, and we are talking about hundreds of antennas installed, miniaturized and installed within a single communication device. And also we have a lot of machine learning and decision making, which is happening and pervading almost all the things that I said before: smart cities, vehicular network, edge computing, multimedia, new communication paradigm. All of them are making extensive use of machine learning in order to optimize the system, in order to improve the performance. So this is also something that we are, as modern ICT engineers, are becoming very interested in, and we need to specialize on. Then we have network and information security, which is, as you know now, with what is happening today, is becoming very, very important. And we need to, and we do offer like a significant number of courses on this as well. So this is a view of the modern ICT engineer. I think a modern ICT engineer has to have tools, and the tools are basically the solid mathematical background tools that I'm sure, algebra, geometry, probability, and so on, that you were exposed to those tools already from the bachelor, from the first 3 years. And I'm sure that most of you are already very strong in that. On top of this, we need nowadays some cross-disciplinary tools that are about the programming. So we are interested in you being able to program embedded and internet-based systems, but possibly with C and C++ language. And we have a dedicated course on programming for ICT here that we offer at the master. We are interested, we would like you to become expert in Python programming, because this is especially useful when it comes to scientific computing, machine learning, and system integration. So you have an ICT system, you want to embed some intelligence into it through the machine learning, and also maybe you want to integrate the different parts of the system in order to construct, to build a full set of, from isolated element to have an integrated system operating efficiently. Also, Python is being used for that sometimes. So those two languages, I would say, are becoming milestones that we would like you to become quite knowledgeable about. Then, of course, I believe a modern engineer should be very skilled in machine learning, and he should know what is classification, feature extraction, unsupervised versus supervised learning, deep learning, reinforcement, and so on. And we do offer a number of courses that I will going to present to you later on these aspects. And finally, so I would say, last but not least, we need an engineer to become expert, to have some knowledge about optimization theory and methods. So we are talking about convex optimization in order for or sequential optimization for networking. So an engineer should be able nowadays to have mathematical and technological tools so that it can optimize the system that is building, not only designing the system, but also designing a system for optimal performance. And there are techniques within the optimization theory that help you to do that. And also here we have a number of courses that, of course, I will mention probably later on. Then the modern ICT engineer, besides the cross-disciplinary tools that I have described, needs to have some solid background on modern ICT technology. And I'm talking about communication technology like the modern 5G, but I should also add 6G nowadays, systems, Wi-Fi, wireless fidelity, so the Wi-Fi technology and its evolution into the future, internet protocol, networking protocol. Then we are talking about signal processing and transmission and compression for multimedia signals, and the transmission media, they are very important. So all the fiber optics, antennas, millimeter wave communication, photonics, and so on. Of course, with this 2-year master, you cannot become expert in all those things. You need to select, you need to make a choice. There are as I was mentioning at the beginning, 8 different tracks that you can select upon. Your study plan is designed, is conceived in order to be very flexible, but this is now uncovering the broad area, and then we see for each track what are the topics and what are the courses. And also, you should, an engineer should be delving and should be deepening knowledge on specific application domains. Application domains that we cover in this master degree are especially ICT for Industry 4.0, sensing system, Internet of Things systems, ICT for healthcare, e-health, and so on and so forth. And you're going to see more later on that, because we put some slides on specific, let's say, application domains, also in terms of a little bit of research developments that we are doing. So what is it? This MIND master is a modern and flexible master degree, 2 years, which is designed and centered around ICT technology, ICT tools, with an eye on modern ICT systems and modern ICT applications. It allows you to shape your study plan in terms of the type of technology that you are interested in terms of the cross-disciplinary tools that you are more interested in, by choosing a little bit between the programming technology, the machine learning technology, and the optimization technology, and also by focusing on the application domain that you are that it is most appealing to you. So what we do now, we look at in detail, a little bit more detail, at the study path that we have. In this slide, you see the main structure. So we have 4 curricula, C1, C2, C3, and C4. And for each curriculum, you have 2 tracks. Basically, I use the T for the tracks and C for the curriculum. And then what we do now, we go one by one, and we look into a little bit more details for each one of them. Okay. Okay. First of all, you can stop me. You can also, maybe not all of you at the same time, but if you have a question, you can stop me and we can discuss. Okay. You can make it interactive. Second of all, when I finish, when myself and my colleagues will be finishing with this presentation, we are invited, and we would love to receive questions. This is also very possible. And that's it. So we start with the number 1, with communications. What I wanted to do here is just to emphasize a few of the main themes that we are going to cover within this master degree. So as you can see, we have 5G, but nowadays this is also going towards the 6G mobile networks. As I was mentioning here, we have a lot of communication technology involved, also using massive antennas, massive antenna technology. We have new communication paradigms also covering communication under the sea, under the ocean. We have this Internet of Things technology, which is really becoming pervasive, which is about communicating and transmitting data in smart cities that are becoming sensing systems, basically. So basically, smart city nowadays, you have a lot of intelligent system installed to monitor all the things that are happening for safety, for traffic control, pollution control, and so on and so forth. And all that technology, we call it wireless sensor network technology, and they also call it Internet of Things because it became like a buzzword for that. All this technology is designed, is ICT designed around the ICT that we have here. Especially as long as the collection of information, so the information sensing and the transmission of the sense information to the network edge is concerned. Also, this is about some of the communication technologies that are covered within the course, but I wanted to mention here, which is something that we do as part of our research also. Nowadays, communication through a radio is not only about sending data, but it's also about sensing the environment. So what we have here, we have just an example of Wi-Fi. what you can have, the access point that you may have in your house, and a computer. And this is showing you how the signal is transmitted and received. And then you have a person in between. And the idea is that by exploiting at the receiver or at the access point, the way in which the person reflects, bounces off the wireless signal, that what we can do, we can detect the person, and we can also maybe identify, track how the person is moving within the environment. So we are building a sort of radar tracking system out of radio waves. This is an example of what we did in our research work in our lab. And you see that we have two people working and we are tracking them through radar technology. This radar technology is operating at millimeter waves by using some of those boards that we have here. You see, in each one of the boards, we have several antennas that are printed on the boards, and we are exploiting the transmission from those antennas to track the people that are moving within the environment. And all that implies a lot of know-how in terms of, removing the noise, because you can see here, there is a lot of noise around, a lot of points that are neglected because they are noisy points. And instead, the algorithm will be able to detect the true part, the part that reveals the presence of the person. So this is just to tell you, there are a lot of cool things that we do that are about not only the communication per se, but are also about the sensing field and the tracking field. This technology is becoming especially important for vehicular networks, for example, for smart cars, because the radar technology will be used in smart cars in order to detect, the people or other cars in front, and will be very valuable for that. So here, what we do, we look at the tracks that are available, T1 and T2 for this first curriculum that we offer. And for each track, we have it is not complete, it's a non-exhaustive list of courses that we have. So you see that here, courses that are related subjects to this track are wireless network, digital communication, 5G systems, optical networks, and we have some courses on antennas, millimeter wave devices, visible light and meta surfaces, communication. DSP stands for digital signal processing, satellite system, fiber optics, information theory. At the end here, in the final bullet, we have the courses that are optimization, machine learning, and programming. And you can choose which one, or maybe even more than one, you want to attend, basically. So those are typical topics for this curriculum, for this track. The second track is still belonging to the first curriculum, C1. It is oriented more towards the Industry 4.0 concept. So basically here, you still have some courses that are the same: wireless network, digital communication, 5G systems, antennas. But then you have other courses that are communication network design and internet that are differing. Also, ICT for industrial application is a brand new course, which is it's a new course where you have a number of companies that are collaborating with us, that are basically collaborating within the course in order to present real problems from their own industrial businesses. And then we present those problems to the students. We have some parts that are theoretical, some parts that are applied. The companies are also presenting their seminars. And at the end, the student will be asked to work on those, on some projects, basically, that are oriented toward the real industry. So this is actually, the first edition of the course was the last year, and it was pretty successful. So yeah, it's worth mentioning. Then we have a course on IoT and smart cities, digital forensics, computer vision, programming for telecommunication, programmable hardware devices, which is oriented towards programming embedded systems. So here you learn how to program the microchip that goes into the sensing system, for example. Then you have optimization methods for ICT, which is a course that was designed specifically for the ICT, this track here, for the ICT MIME master degree. And this is providing you with methods, with algorithms to perform optimization of resources that are especially useful, as I was mentioning, within the ICT domain, but not only within the ICT domain. And then we have also machine learning, of course. Then what we do now, we go to the second curriculum, which is about networking. Here you see I have depicted a little bit a view of what is nowadays a mobile system, a cellular network. A cellular network nowadays communicates with moving, of course, with people, with us, but also in the future with cars and moving objects, because we are also providing communication, as I was mentioning, capabilities to cars and other objects around. So we need to deal with this mobility in the communication. And beside communication, what's going on here is this multi-access edge computing, MEC, which is a new paradigm that involves the computation at the access point. So the access point is not only providing a sort of channel for the user to communicate the data, but is also providing computation capabilities and storing and data storing capabilities for the final user. All this system is integrated and it communicates with the cloud computing facilities where, so you see, you have some of the computation that is happening in the cloud, some of the computation is happening at the edge of the network, so at the base station themselves, where we have some edge computers there. And then maybe some computation, a little bit, is also going on at the end users in the cars themselves. And we need to manage and coordinate all this processing, which is a distributed processing around the network, right, together with the communication aspect. We would like this processing to be especially efficient. We would like to be energy efficient, because energy is a big problem nowadays, and so on and so forth. So this is for sure a new view about, let's say, mobile networks. The message here is that modern mobile networks are not just dealing with communication, but also with machine learning and computation, especially at the edge of the network. So there is a lot of, let's say, cross-cutting technology, cross-disciplinarity there nowadays also. Security, of course, I don't even have to mention how important it's becoming. And we need to provide secure satellite positioning system. We need to ensure privacy and data protection for internet-based network system. We are also offering advanced courses in a very, very cool advanced topics like quantum cryptography. This is a typical track for internet and security. So you see the courses here are internet, computer vision, then wireless network, and also network science, which is actually a theoretical course about the theory behind a network of devices, right? Network of devices, but also a community of people. So this theory also applies to a community of people who share information in Instagram or Facebook or somewhere else. So it's basically the theory within communicating entities that organize in a network, as a network of agents or people or devices that communicate. Then we have communication network design, which will teach you how to perform the modeling of a network and also the simulation of a network, which is very important. Digital signal processing, a very successful course, which is game theory, which is actually quite mathematical, but is very appreciated, not only by ICT people. Then we have network analysis and simulation. Also here you have an analysis of networks and simulation, especially writing a software to simulate the network. Network coding, which is it's a technology that allows you to protect your information in a network, not from security point of view, but for the robustness point of view. So you would like your information to be transmitted reliably. Okay, so you want that to be received without errors, basically. Then we have web application, foundation of databases, information security, cryptography, and then a number of courses at the end here you see that you can choose from that are related to machine learning, neural networks, and deep learning. So this neural networks and deep learning is an advanced course on deep learning technology, which is on top of the machine learning course, which is here. So we are offering both machine learning and neural networks and deep learning, which is coming, let's say, after, let's say, at least in terms of content. Then we have, again, optimization methods for ICT and scientific computing with Python. It is a new entry, which is dedicated to learning the Python language with an eye on the computing aspect, especially. I would hand over to Federica here for this multimedia track.
Okay, yeah, so basically what happens when we're talking about multimedia, we're talking about something that, as Michele was mentioning in the beginning of the talk, is pervasive. And with pervasivity, it means that now we're using multimedia communication to stream our presentation, and then we use multimedia every day on our mobile phone. And then we can go to some more, let's say, sophisticated systems. So here I have for you just a few examples of the hardware that you can also experience once you get into this track. So you have, for example, virtual reality. I don't know if you ever tried. Usually when I asked the students, they told me that at least once for gaming purposes they tried. So we study this kind of devices, and I'll give you some more details, or we go into augmented reality. So you end up with something like that, very, let's say, heavy and bulky glasses, but they allow you to see things that are not present in real life. So what we're studying concerning this, like virtual and augmented reality, basically, are the way we can create this content, but not only that, also how to render this to the people that are using. So, or how do you feel when you're using those devices? Do you have a headache? For example, are you feeling happy to use it or not? But we'll also focus on the communication, because this is not only a question of visualizing things, but also how to compress them, to stream them. So we will cover many, many aspects of the multimedia communication chain that probably you've already seen in your bachelor studies. And this is only one part, so the more classical idea of multimedia that you have. But when we're talking about multimedia, we're also entering into another completely new world, that is the world of autonomous driving and automotive, for example. So I think all of you have heard at least once, and actually I'm very fascinated about that, the possibility of entering a car and having it going around, understanding what's surrounding it, and not to bump into other cars or pedestrians, finding the way, parking by itself. So no, this is something that is part of multimedia as well. And in this case, you're going to see many new devices. So for example, here you have listed in the slide like LiDARs or radars as well, depth cameras, a lot of different types of hardware. And at the same time, different types of content. So point clouds, 2D, 3D imaging, and all these things will be packed together, because you need to get the tools to study and to work with them. So Michele, you can go to the next slide. Our aim is not only to, we have decided this path, not only to give you an idea of the application that can be done, but also to give you the tools to become engineers who are able to really be active in this field. And especially for this track, you see you have multimedia and digital arts. So we also put a focus on a specific type of application, that is arts. And this is something that is very well known and well spread. I don't know if it happened to you to visit an exhibition lately, but usually you have some components that are like interactive or allow you to explore this multimedia content of versions of the digital arts. And basically for doing this, you need to get knowledge about also theoretical stuff, not only, let's say, application and practical ones. And this is a top, you can find here in the slide some topics that are interesting and that are studied in this path. So of course you have internet, because this is the mean that we use basically for transmitting our multimedia communication. And then you go to computer vision, that is tightly linked to the following courses: that digital interactive multimedia, multimedia coding, and 3D augmented reality. So you will get to know exactly how the human visual system works, and how all these, usually say Instagram related applications, filters, everything that is related to image processing work. And this is like the foundations of what you will explore later on. So you'll move in complexity in digital interactive multimedia and multimedia coding, because if we want to stream something, we need to compress it, especially with the high resolution content that we have nowadays. And then you can challenge yourself in building up 3D models. And this is actually a very nice course where you can challenge yourself. And then you have digital signal processing. As you can see, there are quite many overlaps with the other tracks as well, because our idea is to give a solid foundation, I mean, to provide the student with some very theoretical tools that can be used in different types of applications. And then there are some specific other courses like digital forensics that is more oriented to the security of the multimedia information. And then you will see natural language processing, human-computer interaction, video communication, and user experience. So here you consider also the man in the loop. And this is basically due to the fact that, as I've shown you with these devices that we have, when we're talking about multimedia, one big player is the final user, because you wouldn't really use a mobile phone or a device that is not user-friendly or that doesn't give a very good experience. So those things are related to these aspects, not only, but partially in this. And finally, you will get some tools that are absolutely necessary nowadays. It's like the alphabet for us, so machine learning, neural networks, and deep learning, reinforcement learning. And those are all things that will be part of your bag of expertise that you can use also in several other fields. And I think that's it, Michele, for this multimedia.
Thank you. So I would move on with Luca now, Professor Palmieri.
Yes, thank you, Michele. Good afternoon, everyone. So I'm Luca Palmieri. I'm going to present you the third curriculum of ICT for Internet and Multimedia, which is Photonics and Quantum Engineering. So what is photonics in general? What is this curriculum about? So photonics, widely speaking, is the science of light. Of course, it's an extremely wide topic, and it includes even lighting systems and information system. Within our master degree, of course, we are more interested in the use you can have of, you can make of light to, let's say, handle, transmit, or collect, elaborate information, process information. So just to be very specific, I think that a key technology behind photonics is the optical fiber. You all know what is an optical fiber. Nowadays, we are receiving more and more the optical fibers up to our houses, our building. And what is shown here in this slide, in the top left, top right figure, there is a map of the underwater optical fiber communication network, which is basically one of the key components of the internet you're using every day for such diverse system. Because as we have seen, ICT includes in itself a lot of different technologies, services, knowledge, and one of them is what is called the physical layer. It's basically the physical devices that are needed in order to implement, loosely speaking, an ICT service. So the optical fiber is, for example, a ubiquitous transmission channel. And in this curriculum, one of the things that we offer to the student is the opportunity to understand how this transmission system, transmission channel works, the way in which it can be designed, optimized, also providing, which is most important, especially for the point of view of a student, perspective on future activities. Because do not think that transmitting information is nowadays something that you can do so easily. We are so used to exchange quite an amount of data at a relatively high rate, but most of the people is not aware of what is happening under the hood. mean, there is a very richful technological effort, of which optical fiber is just one element. There are many, many, many other. And this infrastructure is constantly put under pressure by the users because we are kind of greedy of bandwidth and asking for more and more services. So there is still a lot of research ongoing on these topics. But photonics is not just that, it's not just transmitting information at a very long distance, it's also making new integrated devices, like the bottom right figures is providing you an example of a field which is called nanophotonics. It's about studying the interaction between light and matter and structures which have detail on a nanometer scale. Why would I like to do that? Well, because as that picture is suggesting, you can in that way convince light to do things quite weird, like those sharp bands that are represented in the simulation. The yellow and blue spots in the figure, they're basically representing a light wave propagating in that nanophotonic structure. You know probably that light likes to go straight forward. If it is inside an optical fiber, it follows an optical fiber, but convincing light to make a tight band is not that easy. This is something that is done with these nanophotonics devices. And the reason why these are studied and people is doing a lot of research activity on this kind of integrated devices is because they are seen as a possible mean to do data processing to process light in order to increase performances of system that could be transmission system, which are the main focus on ICT, but not only that, because light can also be used to do sensing, which means to collect information. So the optical fiber itself, for example, could be used as a sensor. And nowadays, there are research groups, including ours, that are basically using those submarine cables to, for example, detect earthquakes or other relevant geophysical parameters, just because those fibers can act as sort of interferometers. I'm not going to, it's not the right place where to go into the details, but if you have an idea of what an interferometer is, if you heard about gravitational waves and the way you can detect them, well, this can be done to some extent also with optical fibers and photonics in general. And just an example of the use of light as a sensing system, or more in general as an imaging system. There is the last picture in this slide, the one on the left, which is representing the blood vessel structure of a human tissue, of a portion of a human tissue. And that is being collected by a specific bioimaging system based on light. And this is an example of the great advantages you can have using light, because you might have noticed that light can go to some deep depth into the tissues. And in that way, you can collect information from inside the tissue without actually going to surgery and opening the tissue itself. It's what is called, it's an aspect of what is called in general biophotonics, a very broad subfield of photonics itself, which studies the application of light to the biomedical issues and problems. You might be somehow surprised that there are like biophotonics activity within a master degree, which is called ICT for Internet and Multimedia. But you have to understand also, and I think that this presentation is giving you this idea, that this kind of labels, this kind of names, they do provide a perspective. So they are telling you that they're going to study something in the perspective of information and communication technologies, but the boundary of this concept is not so sharp, are not so sharp. They are actually fuzzy, and soon afterward, you can find yourself in a nearby field. So this is why you can find also bio-related stuff in this master degree, as you will see also in the final curriculum that is going to be presented in a while. Going to the next aspect related to photonics is quantum information. Now, this is an example of, let's say, fuzzy boundary between the two topics, because once you start talking about light, it's natural to start talking about light in terms of classical waves. But soon after you recall yourself that there's been this very fundamental scientific revolution in the 20th century about the quantum mechanics and quantum description of the world that is surrounding us, and of course also light as a quantum nature at some level. Now, this is kind of a disruptive aspect that is very quickly summarized in that picture you have about the classical bit and qubit you have in this slide. Because, you know, if you want to encode information on a wave, on a classical wave, like you want to encode a bit, you can, for example, use the amplitude of the wave. So if there is light, you're transmitting bit 1. If there is no light, you're transmitting 0. And this applies even if you use acoustic wave. Earlier, submarine acoustic communication were mentioned. Even in that case, in principle, you can use an acoustic wave to send bit 1. No wave, it's bit 0. If you go into the quantum domain, this picture is completely changed because you can use something that only exists in the quantum level, which is entanglement, which is the ability of two quantum systems, like could be two photons, to be intimately linked, entangled between them. And this paves the way to all sorts of new applications that cannot be done with classical systems and that are now quite an hot topics of research. Here in this slide, there are two main examples. One has been already mentioned, is secure communication. The idea of using quantum state to exchange in a very highly secure way code words, basically, with which then you can encode the channel and achieve secure communication. But there is also another application which you see there, which is a perfect random number generator. It might be silly. Probably you have some experience about MATLAB providing you a random number generator, but those are actually not random numbers. They look like random, but they are generated by a deterministic algorithm. If you want to do something really random, it's not at all that easy. And the best way we know nowadays to do that is to use this quantum characteristic of light. So within ICT, we focus on what is called quantum information, which is the way of using these quantum properties to handle, again, transmit or process information. And this brings you to a whole new language that has to be learned, the language of quantum information, new application like the one I mentioned here, or like quantum computing, which is a sort of holy grails that a lot of people is researching around the world. So as an example of tracks, we see here an example of tracks in photonics. In both cases, also you will see in tracks of quantum information, the starting point is, of course, in fiber optics because it provides you the background knowledge about how to describe light propagation, which is the key element before you can do anything else like propagation. So you have to know how to describe that. But then there are other courses that are covering more like devices. Photonics devices is describing some of integrated devices. Molecular photonics is going towards the interaction between the application of, the interaction between light and matter and the application of this interaction to some sensing fields like photonic applied to agriculture or the food security and sensing application in that case. Staying on the classical level, then you have optical networks, which is a course introducing the key concept, these key devices behind the internet, the cabled internet, so the optical networks, fiber optic networks, devices like the optical fiber amplifiers, which is essential to our society, but very few people have ever heard about the optical fiber amplifier. And besides that, you also have those courses that are nearby photonics, like optical and quantum communication, again, describing how you can communicate using photonics and quantum properties of light, but also other not strictly related topics like the one described here by antennas, satellite communication system, millimeter wave devices. Those are more related to radio waves. Strictly speaking, it's not photonics, but you might imagine how important those are to an ICT system and to our society in general. And besides, as with previous track, we want to offer you a general information, not too tightly focused on one specific concept. So you can find other courses like the one suggested here, natural language processing or programmable hardware devices, just to make some examples. For what concerns quantum information, the asset is similar. The main difference is that there is, of course, a tighter focus on quantum aspects of light and its usage. So you have courses, a fundamental course, which is mandatory for this track, which is quantum information and computing, which is providing you, as I was saying before, the basic knowledge, introducing you to the language and formalism to describe quantum information and see the application to computing. And then you have other similar courses like quantum methods for ICT and new courses about quantum technologies, quantum optics and lasers, which is going a little bit more in detail on the devices you need to create a quantum state, which is basically the laser and some specific add-ons, let's say that way. Quantum cryptography has been already mentioned. And as before, even in this track, you have the opportunity to widen your knowledge, not only in photonics, but also in ICT related topics. And just to conclude, as I already mentioned, this topic about photonics and quantum information that I just mentioned also argument of research in our department. Myself and a lot of colleagues in this department do active research in these fields. And this is also guarantees that when you take these courses, you always receive the most updated information and quite interesting perspective on the future of these technologies and methodologies. And that's it.
Thank you so much, Luca. So I take over from here. I introduce ICT for Life and Health, which is the last curriculum. And here, what we deal mainly is the collection of information from human beings. So here we are still dealing with information, but coming from human beings, actually. So this is actually about wearable technology, human data processing in terms of collection of the data itself, the compression of the data, the quantization, the transmission of the data through some ICT-based system. Here you have an example of ECG sensor, and we need to compress the data to transmit it to an access point and then into a web-based and cloud-based system for storing the signal and also possibly processing it to detect anomalies. We are dealing with the real-time communication for medical applications. We are also dealing with some technology, which is software, actually, machine learning technology to manipulate and to understand the data that is generated by human beings, like walking behavior in terms of accelerometers and gyroscope, which are sensors that you have in your devices in the smartphone. You have a lot of those things. They are becoming also quite accurate right now. But what we do, we study the technology, the processing technology that we need to understand those signals and to to make decisions based on that. Also, speech feature extraction, speech recognition, natural language processing things are related to this track, to this curriculum. And also, here I have an example on how to design and implement a convolutional neural network to detect automatically within an image. This is basically an X-ray image of the lungs. And what we have on top is the manually annotated problem area, the disease area from patients, annotated by an expert, by a doctor. And in the middle here, you have the annotation that is automatically found by a neural network. So basically, the idea is to train some machine learning technology in order to automatically detect diseases and to be very precise in that. Especially, and here we are dealing with the image field, but we can do the same thing also for other signals like the speech, like the blood pressure. We can operate on the respiration rate, on the movement patterns, and so on and so forth. So here we have two tracks. Track number one is, you see the typical courses are e-health. Then we have machine learning, precision medicine, human data analytics, then computational genomics, life and data epidemiology, neurorobotic, neurorehabilitation, sport engineering, and rehabilitation devices. So the names are quite let's say, expressing the topics that are contained in the course. Then here also we have neural networks and deep learning, scientific computing with Python, because those things are absolutely very much needed for this medical ICT track. And in the last track number 8, you see the subjects are similar. Most of the subjects are in common, but there are some here. The emphasis in track number 8 is put on the machine learning aspect of that. So we have more courses in neural networks and deep learning, reinforcement learning, again, scientific computing, computer vision, neuroimaging. We have a new course on biological data also. And still human-computer interaction and natural language processing. So as you can see, so this is a quite comprehensive, let's say, overview of what we offer. We have many things, and depending on your attitude and on your interest, you can focus on a specific curriculum and on a specific track, right, as we have mentioned. I want to stress the fact that I thank Luca for that. All the professors here are absolutely researchers and are actively performing research on the topics that were presented. So you will be, during the courses, you will be exposed to the most up-to-date technology within the ICT field, within the signal processing and multimedia and so on and so forth. And you will also have a chance of getting in touch with our labs, with our lab activities, and maybe in the future to become part of our groups, of our research groups. This is a typical study plan, how it is structured. So we have 2 years, 4 semesters. You see in year number 1, you have 18 credits that are the red 18 credits that are mandatory. These are specific subjects that are specific to the curriculum that you have selected. So those are mandatory. Then you have 12 more credits. All the exams in the study plan are worth 6 credits. So when I say 18, this means 3 courses. 12, I mean 2 courses. In the second semester, you have 30 credits about exams. And then in the third semester, you have 24 credits with exams and the remaining 6 with soft skills. The fourth semester, typically, we go for an internship or a research training activity and a master thesis. And then on top of that, it may be possible, if you're interested, to go for an Erasmus period, and that is quite flexible. Also, this is a typical splitting of the credits distribution. This is a typical view. There is flexibility on when to take the mandatory credits and when to take the soft skills or the internship training. Okay, we have more Now, just for track number 2, I give you an example, which is a more detailed example on how to we go about selecting the study path, basically. Let's take track number 2. For track number 2, you have 3 courses, 18 credits, 6 credits each, that are the courses on top here. Those are mandatory. Those mandatory courses will be always in the first semester, so that you can take them from the beginning. Then you need to choose 5 courses out to those here in the blue box, and this is about 30 credits overall. And for this track, you see that the courses are communication network design, digital forensics. Those are all courses that are very much aligned with this type of technology and topic that we cover in this track, okay? And then we have 3 courses which are worth 18 credits in the yellowish here, orangish box, which are still related, but a little bit more cross-disciplinary oriented. So we have big data computing, cryptography, foundational databases, optimization methods, scientific computing, reinforcement learning, web applications. And then you have 6 credits that you need to take on soft skills. We have some exams on public speaking lab, which is quite appreciated. Also, project management is very much appreciated. Public values in media and ICT, and the B2 English credit for a B2 certificate. Then we have 12 credits that are 2 courses that are a free choice. Of course, this free choice it is not entirely free in the sense, just for you to understand, if you choose a course on Italian literature in the Renaissance, probably this one will not be accepted, but it will be free as long as the course has some technical value for an engineer, let's say. So if you choose a course on marketing, if you choose a course on even other departments, but still related, that can add the value to what you are doing as an engineer, this is accepted. So it's free, but with a little bit of attention not to take something completely off, right? That is not related to what you want to be. Then we have 6 credits here from another subject at your choice from the entire MIME offer that we have in this master degree. And then you need to choose one among the internship, between the internship of the research training, what they are. In the last semester, so I said here, if you go back in the 4th semester, typically we like the student to have finished with the exams, as you can see, and just to concentrate on the internship activity and on the master thesis activity. So an internship activity is carried out within typically the industry, one of our industrial partners. So we have quite a few of them. So you will have a possibility of talking to them and also of selecting like a place to go for a few months. Typically it's between 2.5 and 4 months, depending on the type of activity, but we are quite flexible. And then to go and to experience some real work within an industry. This is the internship activity. After that, you come back and you work on your final thesis. The thesis and the internship can also be combined. Sometimes the students like to combine these 2 things because it's if you do something in the internship that is very interesting, you want to continue with that, then you have a tutor at the university, you have a tutor at the company, and then they can talk and they can extend the internship work into a final thesis, and then you conclude your studies with that. Or you can go for a research training. A research training is actually a research training activity that you perform here in one of our research labs. So this is a second opportunity. Maybe it's more research oriented. And here you can experiment with the topics that we are studying within our research groups. You can develop the system that we're working on. And some of them were presented before, some of them you haven't seen. But so we have these 2 flavors, basically. You go into the industrial world, or you stay here a little bit and you focus on research-oriented training within the labs. And the total is 120 credits, and this will conclude your education for the master degree. So a similar path in a similar set of choices, so the structure is identical, is for every one of the tracks that we have presented to you. So for the internship, I'm just going quickly, just put some examples for the communication fields. Those here are the companies that we are in touch with. You see there are also some big names there, like Huawei, Telenor in Norway, Wind, World Sensing in Spain. So we have a lot of, let's say, partners that collaborate with us. With the multimedia field, we have Sony and Nokia Bell Labs and so on and so forth. Photonics, we have other big companies like Infineon, Leonardo. Then also we have smaller companies like Adams that are local. So there is a selection of choices. ICT for healthcare, we have some companies that are like Malvestio, Chimea, and so on and so forth. Important to know is that in November each year, we have a dedicated meeting organized by our Professor Tomasin, who is our internship responsible. And it will be organized also this year in November, where what we do is we organize a day where people, students, meet companies. So people from the company meet the students from the degree, and this is a wonderful opportunity for the companies to exchange and to tell the students what they are looking for. What are their projects? What are the topics that they would like to solve, right? And for the student to talk to the companies and to select, the best one for the internship that they would be interested in. So this is actually happening every year, and we believe is quite important. Let me go through the questions. I'm a bit worried about the courses with programming languages. There is a time in these 2 years to learn well from zero all these things. What is the mean of the student in multimedia and digital art to complete? The second one, I would leave it to Federica. The first one I asked, I will respond myself. I have the basic skills in programming, but if you please clarify the objective, would be great. Okay. Okay, when Mr. Michalowski mentioned networking, was mentioning path, cyber system, or track, internet and security. So basically for networking, especially, let me go back quickly so I respond to that, which is quick. Networking here is especially in track number 3, internet and security. So this is about internet system as a whole. So you have the focus on the networks, on communication networks. For the programming is like pervasive. So we need programming everywhere. You don't need to be, let's say, concerned or worried about the programming skills. I believe here, a day in this department, you were exposed to programming languages like Java or maybe MATLAB in the first years, like in the 3 years. What we do here is basically expanding, and of course you can select according to your preference whether you want to go for C, C++, and this is especially needed if you want to go communication technologies or smart industry, because those are languages that are appreciated for embedded system programming. And in the industry especially. If you're more interested in the probably, let's say, just the other extreme, ICT for life and health, but also cyber systems, maybe what is interesting for you is Python programming language. So it's not that you have to learn everything that we offer. You need to select according to your interest. And of course, in the Python programming, we have a main course, which is scientific computing with Python. You can take it, you cannot also. And then all the courses that we offer in the machine learning domain are using Python, because of course, Python is the machine learning language nowadays. We cannot do anything about it. Python has become the machine learning unofficial, let's call it as you want. It is the machine learning language. So if you want to program machine learning and somehow learning systems, you need to know, but it's not difficult, because in all the courses that we offer, we have a theoretical part and we have a lab part, the laboratory part. And in every course, you will see that in every lab part, you will be exposed over and over to the same Python language. So at the end of the program, you will know how to program in Python, I'm telling you. And this is not for geniuses, it's for everybody. So we have, let's say, designed this in order to be understandable. But I guess you got the point. Yes, Federica, you want to answer number 2 here? Because I don't understand it very well.
Yes, the question is, what is the mean of the students in multimedia and digital arts to complete a degree? And actually, Matteo, I'm sorry, I don't have the figures with me, so I cannot tell you a number. But what I can tell you is that, as Miguel already said, is that you will acquire all the needed skills during the master. I mean, we don't give for granted that you know already everything. So of course, we'll teach you how to get to the point. And the other thing, as was mentioned earlier, the selection of the courses is pretty flexible. So for example, you won't choose, I mean, if you are not really into programming, you don't really want to deepen that side of your educational training, then in that case you can focus on other types of courses.
Focus on other topics, of course. Programming is always useful, but you can also take other things.
Yeah, it's good. Let's say it's good to have a foundation of programming, because this is something you would use also in the job afterwards.
Absolutely. And we have a committee here dealing with, I go back to the International by Design. Now we're going to move on with Federica on the last part, but before we move, I just want to mention that we have a study plan committee, so they are in charge of helping you guys to select the right track and to also personalize the right track for you according to the interest, according to your so as Federica was mentioning, it's not that every one of you should be taking all the programming courses, all the machine learning courses. That would be too much, but it is, the offer is ample, so you have choices and you have freedom to move around. Okay, good. So we move on, Federica, if you want to.
Yes. Okay. I'll add one last thing on the courses. Sorry. There's a website that was mentioned in the beginning. There's also the reference link later on in the slide, myme@unipd.it. Yes. And it is, I mean, you have all the information and guidelines to create your, your curriculum. So you can check it out. Okay, so I'm wrapping up, and even if I know that now you already are convinced in taking our master in person,
I don't know, but I ask you, Federica, to be a little bit fast here.
Yes, I'll be extremely quick. Yeah, so what I can tell you is that this is a very multicultural international master. As you know, we're speaking in English, so the courses are entirely taught in English. And just for next year, so 2022 to 2023, we have accepted for enrollment 240 international students. Accepted means that most probably less than half of them will join us, because there are also bureaucratic issues. Anyway, we had a lot of applications from 30 different countries. So if Michele, you can go to the next slide. I can show you that they're coming from the entire world. We have, of course, some countries from which, let's say, we are most well known, because we have students that are coming from several years. They're Turkey and Iran. But if you look, But if you look around, you would see that we have people from Mexico, South America, and Philippines. So it's very multicultural. So this is already extremely stimulating. But if you're not an international student and you are Italian, but also if you're international, actually, if you want to exploit the possibility of going around and meeting new cultures, then if you go, Michele, to the next slide, thanks. There are a lot of mobility programs that you can use. So one, I think most of you already know, is called Erasmus Plus. And the Erasmus Plus is made for two purposes. The first will be to go to abroad in another university and or do courses, take some courses that are delivered in these partner universities, or to do there your internship and master thesis. And usually this happens in the second year. So first or second semester of the second year. There are calls throughout the year. Usually you have two of them. I'm the person I'm the contact point for these activities. So if you need further details, just contact me. I'll be happy to answer any question. Similarly to Erasmus Plus, you have Ulisse. And it's exactly the same type of exchange, but this will allow you to travel in non-EU countries in Europe, but also to America, Asia, and Oceania. So to go to go quite, let's say, far away from home. Plus, you have some other options. So there is currently this DCamp. It is called virtual mobility. So you're not physically going to some places, but you will have some courses that will be held online on topics usually related to security, and they're involved in a network of universities around Europe. So this is, again, a very nice opportunity for getting credits on specific set of topics and meeting also, if virtually, students from abroad. That is always an added value for your career and also student life. Finally, you have also a nice option, I think, that is to get a double degree. So we have an agreement with two universities. One it is the Universidad Politécnica de Madrid, so in Spain, while the other one is the National Taiwan University. We have a call once per year in which you can apply for this type of framework. And what happens is that you will carry half of your studies here in Padova, and the other half will be carried out in the host university. And then you will get a double degree. This means the degree title both in Padova and in the partner university. Mm-hmm. So this is really a lot of things. I mean, you can go on the website and find there are many, many more details. And if you're not convinced yet, I'll show you, because of course we are teaching in this master, so we strongly believe in this, in the education that we are providing. But I think the best way to convince you that this is good is to see what other students said about the master. So there is Alma Laurea, I don't know if you know it, is a consortium that basically collects statistics from students about their the pleasantness of their studies, if they're satisfied, what they're doing as a job, and so on. So there is the last one. So this is the 23rd collection of data that refers to people that graduated in 2021. The last available online, and those are some numbers that you can actually use. So you have that after your graduation, after 1 year, so right after your degree, you have your monthly salary that is 1660,000 euros, 1660 euros. Okay. Then the average duration of the studies is 2.2 years, so it's very quick. Students can get to the graduation pretty fast. The average graduation mark is 109.7, so it's pretty high. And you graduate roughly at 25 years. And the nice thing, I think, if you are not willing to pursue a PhD or do any type of research, that if you graduate and then you apply for a job, you will get your first job after 1 month. So that's super quick. Among all the students, let's say the ones that we have and that also had an experience abroad, so that used one of the mobility exchange programs that I've shown you, are 39%. And 1/3 of our students actually got a scholarship. So those are all things that can be of your interest. Then what I really looked into is the employment status. So Alma Laurea asked our students after 1 year they graduated, which was their employment status. As you can see, almost 60% of them was already working, while the percentage, I'm sorry, I cannot see it for some reason, but there is enrolled in a specialization course. That
30%.
Yeah,
30%.
sorry, I don't know why. Okay, I think it's the chat box that is covering things. While you see that not working, not looking for a job, it's a very, okay, now I have it now, it's a very small percentage. And this is after 1 year. Here, this slide tells us what happens after 5 years. So let's say you have some working experience and you can almost, and we get to almost 100% working students. And you can see that the ones that are not working is not because they didn't find a job, but they're not looking for a job for some reason that are not mentioned in the survey. Next one, then of course we wanted to know, is it the professional training that we give? So all these courses we are presented are effective for you in your job. So this is what the people, the students after 1 year replied. So 91% say that it's very adequate. So the courses that we are providing and the level of expertise that we provide is correct. And how much did you use your degree in the job that you're actually doing? So 68% said it's actually it's very effective, the degree that they took. The other 32 said somewhat effective, so we didn't have negative consideration about the effectiveness of the degree. There are several employment fields. So as you say, we have 8 tracks. So you can really use this master to end up in different working places, picking up what you really would like to do. But if you can see, the bigger slices are the information technology, that is the green one. Then you have consulting. And usually when we're talking about consulting, we are talking about consulting companies that are working in the telecommunication or information technology fields. And then the yellow one, that is telecommunication. Then you have a few other, but you say those are the main fields in which you guys will end up most probably. And I think this is the last one. That's the question that is always scary. So would you choose it again? Will you do it again? And more than 90% said yes, I would enroll at the same master degree in the same university. So they really enjoyed the master. Some others said yes, I would enroll, but this is less than, it was, if I remember correctly, 3%. They said yes, but I would enroll in a different master at Padua University. And there's a 3% that say yes, same master in different university. But I would say that 94% is a very high percentage. So I think we can be satisfied of this answer. Admission procedure. So there are 2 different paths, let's say. One is for Italian students that hold an Italian bachelor degree and foreign students. So if you have an Italian degree, you need to have a mark, graduation mark that is equal or larger than 84. And what is needed is that in your bachelor degree, you had 50 credits split in these topics that you can find here. So it's math, physics, computer science, and telecommunication. As expected, if you're coming from information engineering, math, physics, computer science, this is the basic. So you will certainly have this number of credits and you'll get direct admission if you have the 84, the required graduation mark. For international students, I mean, for people that are not holding an Italian degree, Michele, if you can go to the next. Yeah. Then the situation changes slightly, so twice per year, usually November to February and March to May. That goes to September for you students, but I'm not boring you with all those details that are not in now. You can actually, you have 2 chances of applying to our masters. So you need to deliver some documentation like motivation letter and your transcript of records. The strictest requirement that we have is on the GPA. So depending on the country from which you're coming, there's a minimum level of minimum requirement for your GPA value. Once you submit all this data, they will be sent to the committee. And again, I'm part of this committee, so if you need that information, just please contact me. And we will have an interview and decide the students that will be eligible for participating to our master. So I hope I've been quick. Further info, if some informations are missing here, you can contact us at this email. So all of us are reading this email. So if you need specific clarification, just feel free to contact us. Plus the website, again, mime.unipd.it, where you can find all information also related to admission and curricula, mobility, exchange, everything that can be used. Yeah. So, Michele.
Yeah, I saw a question now about the lab experience, the hands-on lab experience, so whether we are only teaching theoretical stuff without exposure to lab activity. No, we have a lot of lab activity. Now I'm talking for myself. I teach a course which is actually human data analytics that you have seen before. In this course is an advanced course related to machine learning, applied to human data, like as I was mentioning, the speech data, the walking behavior data, the ECG data, this kind of stuff. And there, every year we have maybe a little bit more than 1/2 of the course on the theory, and then the rest is in the lab. And what we do is programming neural network architectures for to perform signal processing on human data. So at the end of the day, we are using convolutional neural network, feed-forward neural network, all the classifiers that we need, and we are showing you how to do that in Python. And we have a lab assistant that every year is basically with me, is attending the students, and this is a kind of activity that we have there. Also, I know that neural networks and deep learning course is structured similarly. So you have more than half of the course in terms of theory, but the remaining is all in the lab. Programming, again, the deep learning architecture that you need to become familiar with. I'm sure there are other courses in the multimedia now, Federica, if you know more for that field, that are providing labs, and also in the photonics, I'm sure, because now all the courses are trying to provide, not all the courses, but many courses are trying to provide hands-on experience. For example, in the course related to modeling and simulation, we have a specific lab activity for to build a computer simulator for networks. And this is another thing that is coming to my mind. But I'm sure there are many colleagues that are nowadays offering this type of.
If I may add, Michele, a few words. There are also several courses offering physical laboratory. So you have to think about the laboratory could be, let's say, numerical, broadly speaking, related to activity of designing systems of experiment on a computer environment. But there are also labs that brings you to the lab, allowing you to do hands-on experiments on different fields. For example, in photonics curricula and quantum information curricula, there are several courses that are offering lab activity. There is even one that I'm aware of, which is antennas, where they even do lab activity in a company. One day, the students are brought to the labs of the company and they do experiments there. So really, we do have a rich offer as a master degree, also from that point of view.
Yeah, if I can complement also for the multimedia part, there's plenty of labs, both for, also to relax a bit more Matteo about his concerns about programming. We have like machine learning, has a lot of labs that guide you to learning, for example, machine learning in this case. Then we have 3D and augmented reality, digital forensics, DSP, all of them. I mean, almost all courses have practical labs in which you experience the devices, as I've shown you, but also challenge themselves in, or developing and putting in practice the thing that they learned during the lecture. So yeah, there's a practical aspect. So I think that's really nice.
Definitely. Now I'm asking, this is all. I'm asking the student if they have any additional question for us. We can answer gladly in the next few minutes. Any aspect that you would like to know more? You can also talk if you want. Okay. Let's see. For the application, if there are any deadlines. Zoltan, are you here with us?
Yes, I am here, yes.
Yes, please. Deadlines for applications, they're wondering if there are specific.
Okay.
Yes.
Okay, sorry. Okay, if I may inform you. Well, actually, well, that depends on the title that you hold, because I mean there are two separate situations. Okay, if you hold, I mean, here, as far as I guess, there are mainly students coming from Italy. Okay, so for all of you, you have to check on avvisi di ammissione Unipd. Actually, you have to check on Laurea Magistrali. I will share with you the link I'm also sharing with you the screen. Maybe if you can allow me to share the screen.
You can share the screen.
Okay, thank you. Now, I mean, if you just, you just write on Google avviso ammissione Unipd and you find it here, okay? And you just go to Magistrale. You find it lingua inglese, but there's different, you know, a path. Then you click on Scuola di Ingegneria and you click on Avviso di ammissione. Now, here you have the avviso di ammissione that I'm sharing with you. In order to check it, okay, you can just open it, avviso di ammissione. It is available in 2 languages. This is the one in Italian, and here you have all the deadlines. Now, as you can see, you need, first of all, there will be a period of time, okay, in which you will need to let me see this one in English, maybe for those who will see the video in English at a certain point, but in any case. Okay, the first one is the registration on the UniWeb, because even if you are enrolled now in the bachelor's degree here, you will have another matriculation number and you will have another university career once you graduate at the bachelor degree. So you will need to register again on the portal. Okay, you can use maybe, I mean, if you're already registered, you don't have to, sorry, but then you have to submit a new application for pre-enrollment. This is called the pre-immatricolazione. And you will have, in this case, okay, in order to pre-enroll, let me see if the information is right here. The deadlines and everything, okay, okay. And you will have to assess the minimum curricular requirements, okay? So you will have to check, okay, for the so-called requisiti di ammissione in Italian, which means in order to check if you have the requirements. Where do you see these requirements, okay? So the requirements, you see them in the end. This notice, this regulation, let's say it's available for all the degree courses in engineering, and you will have to check for ICT. Okay, so you will see them somewhere. It's here, this okay one. Yes, at page 25 you see which are the requirements for the Italian students holding a bachelor degree obtained in Italy. Okay, so you need this type of grade for the bachelor degree. Then you need an amount of a certain credits in some scientific areas. Okay, so if you come from information engineering, the bachelor degree of our department, that there's no problem. If you come from other bachelor degrees, then you will have to check, okay, if you hold this type of requirements. Furthermore, you will also need a level B2. If you come from the bachelor degree here, the B2 level obtained, you know, during the bachelor degree is enough for you to enroll for the master degree. Now, getting back, sorry, to the deadlines, there are several deadlines because, you know, you have the pre-enrollment with the request of the evaluation of the assessment of your let's say, let's say the pre-enrollment, and then the assessment of your criteria, let's say of the credits that you have and so on. And so it's done, okay, this time of is done from the 18, sorry, in order to be able to submit the application for enrollment, change of course and so on. I just apologize, one moment, I need to see deadline pre-enrollment during the year. So you will have the indications of the timings here. Admission requirements, 21 October. So here you have the steps, okay? You have different, let's say, timings, okay? But the first of all, you have to submit the minimum requirement curriculum. It's here. So you can do it until the 18th, from the 20th noon on July until the 21st of October. There will be specific periods, okay, according to when you graduate, because you actually, there are generally several, let's say, moments when you can enroll, because some of you might graduate in the bachelor degree by the last period, the last session of graduation, which is in October, okay? And then you can still enroll in the master degree. And this is why you have the deadline until the 21st of October. So you can just proceed, you know, directly with this. Then once you do this, okay, and you have the indication of the commission that you are admitted, then you can proceed with the final enrollment, which can be done still from the 18th of July until no later the 28th of October. And for those who graduate by November and so on, you see you have a timing, you know, a time window until the 31st of January. If you graduate, let's say, by December this year. So the timings are different, okay? There are different timings. And so starting from the 18th of July, you can proceed with the application. So how do you do? First of all, of course, you need to graduate, you need to have the final grade, and you need to have the requirements. Then you pre-enroll, you apply for the assessment of the criteria to be accepted, and then you complete the enrollment. I apologize, but it is not that easy when you say timings.
Yeah, thank you, Zoltan.
Because people graduate from July until December, in July, September, October, November, and maybe even December. And for all of this type of groups of people, there are different periods when they can apply.
Yeah. So thank you so much. So to the students, if they have any other question, that we can take it. Otherwise, I think we can close the meeting here. Please, don't be shy. Take advantage. We're here for you. No? Okay, so if you happen to have questions for us, you can always write to us. The email was in the slides. This presentation will be available, will be uploaded in the institutional channels. And we do thank you very much for your presence, for being here with us. Okay? Bye-bye. I stop recording.
Bye-bye.
Goodbye.
Bye.
Hope to see you soon.
Yes. October, roughly.